You check the weather before you even get out of bed. One glance at the screen, rain today, sun tomorrow. You already know, before your feet touch the floor. For most of human history, that information did not exist inside a device. It lived in the sky, in the soil, and in the memory of people who had watched both for generations. For roughly 12,000 years, Native American nations across this continent had no instruments, no satellites, no radar, and yet, in case after case, they forecast storms days in advance, tracked seasonal shifts down to the week, and built entire calendars around the sun's shifting path across the horizon. How did they do it? With nothing but patience and their own eyes. Around 850 years ago, in a canyon in what is now northwestern New Mexico, a civilization known today as the Ancestral Puebloans faced a problem every farming society eventually faces. They needed to know exactly when to plant, too early, and a late frost kills the crop. Too late, and the growing season runs out before harvest arrives. In a desert that receives less than 10 inches of rain a year, there was no room for error, none, so their solution was carved directly into stone. High atop a sandstone butte called Fajada Butte, 3 massive rock slabs lean against a cliff wall. Sunlight filters through the narrow gaps between them and falls onto 2 spiral petroglyphs carved into the rock behind. In 1977, an artist and independent researcher named Anna Sofar noticed something remarkable while sketching the site. At the summer solstice, a single dagger of light pierced straight through the center of the larger spiral. At the winter solstice, 2 daggers of light framed its outer edges instead. At the spring and autumn equinoxes, a smaller dagger split a second spiral entirely. This was not decoration, it was a calendar, a solar marker precise enough to track the sun's yearly journey to within a single day. Sofar's discovery, later confirmed through years of follow-up observation by her Solstice Project research team, revealed that the people of Chaco Canyon had engineered a working astronomical instrument out of nothing but rock placement and sunlight. No metal tools, no written mathematics as you would recognize it, just centuries of careful observation, encoded into the landscape itself. And they were not alone in this kind of thinking. To the west, the Zuni people held a different kind of knowledge, one passed not through carved stone but through generations of oral memory. In the 1880s, an ethnologist named Frank Hamilton Cushing lived among the Zuni for more than 4 years. He was formally adopted into the tribe, learned their language, and was initiated into their priesthoods. What he documented reshaped how outsiders understood indigenous science. Zuni farmers tracked the rising position of the Pleiades star cluster alongside the sun's shifting location on the horizon, using both to time planting with extraordinary precision. Priests known as the sun priest and the rain priests carried the responsibility of announcing planting dates to the entire community. Their authority rested on decades, sometimes generations, of accumulated observation passed down through ceremony. Anthropologists today have a name for this. They call it traditional ecological knowledge. In plain terms, it means detailed environmental understanding built up over long stretches of direct observation and carried forward through culture rather than through written instruments. This was not guesswork, it was data. It was just recorded in memory, ritual, and stone instead of in a spreadsheet. So picture it for a moment. You are a Zuni farmer. 800 years ago, before dawn, you walk to a fixed point on a mesa your family has used for this exact purpose for generations. You watch where the sun rises against a specific notch carved into the horizon by distant peaks. That notch shifts by a small amount each day. When the sunrise finally lines up with a particular mark, you know it is time to plant. Not because a calendar told you, because the land itself told you, and you had been trained since childhood to read it correctly. Miss the signal, and your family goes hungry before winter. There is no second forecast to check. Farther north and east, Plains nations tracked an entirely different set of signals: sudden shifts in animal behavior, the direction, color, and texture of cloud formations building on the horizon, ants raising their mounds higher before a heavy storm, birds flying low and quiet before a front moved through. None of this was superstition, even though it can sound that way at first. It was pattern recognition, refined and tested across centuries, checked constantly against real consequences. Get it wrong, and people starved, or froze, or lost an entire harvest overnight. Get it right, consistently, for generations, and that knowledge became something closer to a science, even without a single written formula behind it. Notice something about all three of these systems so far: none of them relied on a single lucky guess. Each one was tested, generation after generation, against real weather that either arrived on schedule or did not. A wrong prediction was not an inconvenience, it was a threat to survival itself. That pressure is exactly what turned careful watching into something close to a working science, refined the same way any science is refined, through repeated observation and correction over time. Farther north still, in what is now Wyoming, another structure carried the same idea even higher into the mountains. Near the top of Medicine Mountain sits a massive stone wheel, roughly 80 feet across, its 28 spokes radiating outward from a central cairn like the rim of a giant wagon wheel built from rock. For a long time, outsiders assumed it was purely ceremonial, with no functional purpose beyond ritual. In 1974, an astronomer named John Eddy published research showing something else entirely. Several of the outer cairns lined up precisely with the summer solstice sunrise and sunset, and with the rising points of bright stars including Aldebaran, Rigel, and Sirius, stars that appeared just before dawn at specific times of the growing season. In plain terms, the wheel worked as a seasonal clock built from stone and sky, marking not just the solstice itself but the narrow window of weeks around it when high-altitude camps, hunting patterns, and gatherings were timed to occur. 28 spokes is not a random number either, it closely matches the days in a lunar cycle, suggesting the structure tracked the moon as carefully as it tracked the sun. 3 separate peoples, working in 3 separate environments, arrived at strikingly similar solutions using nothing but rock, shadow, and centuries of patient observation. Here is the twist most people do not expect: this kind of forecasting was not primitive compared to modern meteorology. In some ways, it was more accurate, at least locally. Modern forecasting relies on broad atmospheric models that perform well across large regions, entire states, or provinces at once. Indigenous ecological knowledge, by contrast, was hyperlocal. It was tuned to one specific valley, one specific mesa, one specific bend in a river, refined by people who had watched that exact patch of earth for their entire lives, using observations their parents and grandparents had already tested for decades before they were even born. Where a modern satellite sees a general weather system moving across a map, generational memory saw 100 small, specific signs that no broad model would ever catch: a shift in wind smell, a particular bird returning early, the angle of afternoon shadow on a familiar rock. Archaeology offers even more support for how seriously this environmental knowledge was taken, and how it eventually met its limit. Beginning in the early 1900s, an astronomer named A.E. Douglas developed a method called dendrochronology. In plain terms, that means reading the growth rings of ancient trees like a diary of past climate, since wider rings mean wetter years and narrow rings mean drought. Applying this method to timber recovered from Chaco Canyon's great houses, Douglas and the researchers who followed him were able to map centuries of rainfall and drought across the Southwest with startling precision. Their tree ring data confirmed something devastating. Around the year 1276, a multi-decade dry period now known as the Great Drought settled over the entire region. Even a civilization that had built a solar calendar accurate to the day could not outpredict 2 full decades of collapsing rainfall. By the end of the 1200s, Chaco Canyon and many of the surrounding communities that depended on it had been abandoned. That is the uncomfortable part of this story. Environmental knowledge, no matter how refined, has a limit. You can track the sun with near-perfect accuracy for generations and still lose to a climate shift that nobody alive has ever witnessed before, one with no precedent in living memory to draw from. The ancestral Puebloans did not fail because they were unprepared, or because their system was primitive. They failed because the rules of their environment changed faster than any observational system, however sophisticated, could realistically adjust to. Even a perfect calendar cannot warn you about a drought that has never happened before within anyone's memory. Now think about your own relationship with weather today. You get a forecast instantly, generated by satellites and supercomputers processing more raw data in a single second than a Zuni sun priest could gather across an entire lifetime of watching the sky. That is a genuine leap forward, and nobody is arguing otherwise. But notice what quietly disappeared along the way. You no longer need to know your own sky. You do not track sunrise against a familiar mesa. You do not read cloud shape, or wind direction, or how the ants are building today. Has any of that knowledge actually stopped working, or did you simply stop needing it? The knowledge did not vanish because it failed. It vanished because it was outsourced, entirely and almost invisibly, to a device that fits in your pocket. There is a quiet irony sitting underneath that convenience. the people who built the Sun Dagger at Fajada Butte were not only trying to predict rain, they were tracking their exact place inside a cycle far bigger than themselves, watched with their own eyes, generation after generation, refined by every farmer who woke up before dawn and walked to the same fixed point on the same familiar mesa. You still live inside that same cycle today. The sun still rises at a shifting point on your horizon every single morning, whether you notice it or not. You just never have to look up anymore to know it. You check the weather before you even get out of bed, but somewhere inside that instant tap on a glowing screen is the ghost of a much older habit, one that once required you to actually watch the sky and trust what generations before you had already learned to see there.